Hey everyone, thanks for coming out. It's nice to see you all today. Without further ado.
My name is Ryan Hurlbut. Today I will be talking.
Might have stopped.
My name is Ryan Hurlbut. Today I will be using AI to train AI. You are not actually listening to a recording of my voice. This is
Concludes
just
the
a
presentation.
synthetic voice
Feel free to
generated
hang
by
back
resemble
and ask
model.
any questions if you have them. I hope you have a great day. Fake Ryan voice out.
And so I'm going to be talking a lot about, today about AI and machine learning stuff and data. And this is the kind of data that we're talking about. This is synthetic audio generated by a computer. And this is just a synthetic voice generated by resemble.ai, and that was not me. Let's talk a little bit about myself first. So I'm a North Carolina State University student studying computer science going into my senior year. I've taken a few AI classes while there, and so I have a little bit of background with AI stuff and data science stuff. I'm also a Biomojo intern, so I do a lot of technical stuff, working on processes that we do to implement things in our applications. We'll talk a little bit more about Biomojo in a minute. So back in high school, I was also dual enrolled with Wake Technical Community College, and I was in the simulation and game development program. So I, made video games and rudimentary video game AIs. So that was a lot of fun, and that's where I got my start in computer science. So a little outline before I start the presentation. First, I'll talk a little bit about the introduction, background, motivation behind the work that I did for Biomojo this summer. Then I'm going to talk a little bit about the problem with voice recognition technology, especially as it relates to smaller companies. And then we have an alternative solution that I've been working on this summer, and we'll talk about that. That's using the AI to train AI. And then I'll wrap it all up, tie it all together. And then if you have any questions, feel free to ask. So without further ado, let's talk about voice recognition in the gaming industry. So voice recognition sort of gets a bad rap oftentimes because it's inaccurate, oftentimes unreliable. Think Siri or Alexa. A lot of times it just doesn't accurately transcribe what you're saying. So voice recognition has a lot of potential to increase realism and immersion, and one application for that is virtual reality. So with virtual reality, the focus when you're developing these games is creating a realistic and immersive environment, which is also a great place to learn something because it's very immersive and realistic. So you can learn from practicing things. And because it's virtual reality and augmented space, we can think outside the box with how we control the applications. So we don't have to use a keyboard, controller, and mouse like we do with the PC games or console games. So we can potentially use voice activated commands and even just interact with characters and AIs. We can just really think outside the box with how we interact with these games. So another application, as I said, it's a great learning environment. So the serious game subgenre, which is primarily focused on creating an environment or a situation for people to learn from, increasing decision-making skills, critical thinking, even just learning things. So like if you have a military or casualty care training situation, that might be a really high stress situation for people to practice just being in different environments that might put them out of a comfort zone per se. That's also with healthcare training. We'll go into some examples of these with Biomojo and how we're implementing serious games. And then there's company recruitment games and political persuasion games. There's a wide variety of games that are in the serious games subgenre. So let's talk about Biomojo. We are a small, fast-paced, women-owned business. We focus on biomedical research and development. Our applications are at the cutting edge of machine learning, AI, and mixed reality solutions. So we make virtual reality, mixed reality games, and the focus is on learning environments and serious games. So let's look at a few of our projects that we work on. So one of them is the virtual standardized patients. These are complex interactive AI characters that people can talk to and interact with, and they speak back to you. This uses a lot of natural language processing from sentiment analysis to text to speech, speech to text, intent recognition. There's a lot of language processing that has to go into making these kinds of characters. But the purpose of these AI characters are for students, medical students, who practice history-taking skills and interacting with patients in a clinical or non-clinical setting. And it's a great learning environment for students. Then there's the virtual patient experience. There's a really fun game that Biomojo completed. It's designed to get youth excited about a career in the healthcare industry. They get to play around in hospitals, treat patients, and it educates youth about a career in healthcare. And this is just another example of serious games. Then we have the NXCom's Intelligent Patient Simulation. This picture that you see on the right is a instructor view of a mixed reality application that a student will go into, and then they can monitor, assess, and evaluate patients. They can treat them, and even speak with them and interact with them in the same way as the first game that I spoke about. So this also uses voice recognition technology, which is what I'm actually going to be focusing on today with the topic of the presentation. So voice recognition. A lot of those games, they need voice recognition. And so the standard way that we would do in the past is using Google Speech API, Amazon AWS Transcribe, DeepGram. These are companies that have put together some really powerful speech recognition software for developers like us to use. But they have some pros and they have some cons. So as I said, they're very high quality. Generally for general English, they're trained with very expensive data sets because Google and Amazon have access to those kinds of data sets. And they have a lot of some pre-trained options to specialize into the medical field, or maybe military, as that's the focus here. Now the cons are it's not offline. So a lot of these solutions, they have a server that you ping and then they send back some sort of transcription of the audio. And so internet connection is a real roadblock for these types of games, or for this software, Google, Amazon, these solutions. Oftentimes they can't handle specialized vocabulary. So if you're a small company making a game, these APIs may not necessarily have the vocabulary that you need for your specific application. It's not specialized for you. And even if you want them to specialize it for you, that is going to be extremely expensive. And so this is a really huge roadblock for small companies. Not to mention it's not offline. So there's a lot of cons, and this is something that I've been focusing on in my internship, is improving our speech to text so that it can be offline, work offline and have a specialized vocabulary. So what is this? So what have I been using? I've been using Mozilla Deep Speech. This is an open source speech to text engine. They use machine learning and deep learning techniques to transcribe speech. They are really great for offline speech to text. You can embed their software into your applications. They have a really great pre-trained model. We'll talk a little bit about that model and how it can be used. You can train deep speech for specialized vocabulary, and this is the really big thing for us, is being able to understand medical vocabulary. Because as you can see, we have a lot of biomedical type of applications, and the normal solutions can't recognize that vocabulary, which is a huge problem. It's also free, so that's, as a small company, that's a really big deal as well. Being able to have it offline, customizable, and free, so it's not expensive. And then, so it's great for a smaller company as a result. So the pre-trained model that I mentioned, it has a 7% word error rate, is what they say on their website. What that means is out of 100 words, 7 of them, it'll get wrong. Maybe it'll miss an S or some letter, but it'll incorrectly transcribe about 7 out of 100 words. It was trained with thousands of hours of audiobooks, NPR Talk Radio, Common Voice donations. It's like a public open source donation platform for audio data. And it's really great for general English. So it's a great base model, but it still can't recognize medical terminology. So for example, so if I recorded into an audio file. Deep speech is not very good with basic medical terms like eczema and IBS. What it actually transcribed, and I tested this, is for eczema it said Emma, and for IBS it just said is. So as you can see, it's not great with medical terms, and that's what I've been focusing on, is improving with deep speech. So how does it transcribe speech? Before I can explain what I'm really doing, you need to understand how it actually does that. It uses an algorithm called sequence-to-sequence mapping, which is sequences of sequences of audio waves to sequences of characters. So for example, if you have an audio file that looks like this, it would split it up and try to figure out which characters it maps to based on its pre-trained knowledge. So for example, the first clip would be an N. It would map to that N character, and then C. And then this is where the sequence-to-sequence part comes in, because it's going from sound waves to sequences of characters, and then the A, and then the TE. And that is an example of how it might transcribe. That might not necessarily be exactly what it would do, but that is a general enough representation. So how does it learn how to do this? It needs data. We need lots of data to do this. But what is data? I've said it a few times at this point. What does that mean? It's just an audio file, like a file with sound waves in it. It's a file name associated with that file. It is a size associated with that file. It needs that size so it can like try to cut it up and sort things. You don't necessarily need to know why it needs that, but lastly, it needs a transcript so that it can actually learn what that audio is. You know, what the transcription for that audio is. It needs an actual transcript. So as an example of what I work with is this comma delimited file. So it's just a big spreadsheet with file names in that far left column, and then file sizes in that middle column, and then transcripts. And that's how it associates data. And that is what I'm working with a lot. So what do I do with this data? I split it. It looks a little bit like this for machine learning. You have data that you want to learn from, which is your training data. We call that a training set. And then we have a testing set. This is data that we've pulled from our database, put to the side, and then we use that to evaluate whether or not we learned useful stuff. So if I only feed a model the number 4, it'll get really good at recognizing that. But if I feed it a number 5, we need to be able to generalize to different problems. And that's what the testing set is for. It's just data that it's never looked at and it has not learned from. So as an example of using one of those tests, this is a performance while training graph. So over time training or training steps, this is the word error rate. So how bad it does really. And as you can see, this would be an example of one that learned how to get better on new data. Training, yeah. So here's how you get some of this data. Number one of the more preferred ways is to find free and open source data sets, databases online. However, they're pre-made or being currently made, but they're generally not very useful for specific use cases like ours. Oftentimes they don't have the word eczema or IBS or HPMK blanket, for example. It might not have these words, so you can't learn anything from them that's special for your use case. Then you can go to another company. You can pay for a pre-made solution that they have. These are generally higher quality, less noise in the data. They just higher quality transcriptions and audio, but they're pre-made and not very useful. So we're at the same problem. And this is a problem that we've encountered at Biomojo. And then the third example is paid and custom made. So you can go to a company, they can source data and make it for you. And that's just a really expensive process. So it's also not ideal, especially for a smaller company. We don't necessarily want to go this route because we're just trying to train a few words into our models. Lastly, we can make it ourselves. But this is also time consuming and thus expensive. You have to pay people to go collect data. But that's exactly what I did this summer. So, and it was really, really fun. First, you need a list of sentences. I had about 300 plus. I'll go into my specific process in a moment. Then you have to go to somebody, you say, hey, can you record audio for me? And then they say, sure. And then they're like, why? And then you have to explain why you want them to record random words for you, or random sentences for you. And that also just takes a time, process, time for each person that you go to. Then you send them a recording session. This involves just transcripts that you want them to speak and what you want them to save that under, like what file name to save that under. And I have scripts that sort of do manage this process a little bit. But it's up until this point, they haven't even recorded anything and I've already wasted a lot of time. Then you wait, and sometimes that can take a while. Maybe they forgot, maybe they didn't record it. Or maybe, yeah. So some people are faster, but this is just another time-consuming process. It's just waiting for people to send you data. Then you listen to their recordings, fix file formatting, validate the file formats and all that. It can get kind of complicated. I have scripts that sort of help with this, but this is actually one of the more time-consuming parts of the process. Then you add them to the database. Sometimes you add invalid files and you have to go back, and it's the whole thing just takes forever. It's just not manageable for a small company, which is really what I'm trying to illustrate here, is that for small companies, this is just not a realistic process. If you're trying to add 40 terms to a database, or to a model, I'm sorry, it's just not an efficient process. For example, that waiting period, when people are recording, it usually takes about 4 minutes to get, 60 minutes to get 4 minutes of data. So if I'm recording, I'm recording for an hour, I'll only make 4 minutes of data, when we're really needing something on the scale of hours of data. So what did I do exactly? So spanning over the course of about 3 weeks, talking to about 17 different people, my coworkers, friends, I asking them to speak sentences using 2 vocabulary terms, eczema and IBS. Over those 3 weeks, I managed to collect about 30 to 45 minutes of training data related to those 2 terms, which overall it took other people about 12-ish hours of total recording time. That wasn't my hours, that's other people's recording time. So after using all this data that I collected, as you can see, the performance got a lot better. The error rate went down after, very quickly. That's when that steep slope is the model learning new vocabulary terms. So that's the light blue line, is medical vocabulary. So I also have another line on there called general English, and that's another test set representing general English speech, just normal sentences and normal speaking. Go ahead.
I've got a question. For your data here, recording the error rate for medical vocabulary, were you using only those 2 terms in this test, or were you using more general medical vocabulary?
Good question. I was using only eczema. It was taken from the same data that I collected. So I collected data relevant to eczema and IBS, and then I took out 10%, approximately 7 minutes. I can't remember exactly, but it was from the same set of data. And it's meant to represent what it might see in the actual application, because we have one specific application that uses the word eczema and IBS a lot. So I was trying to train it specifically for that.
Awesome, thank you.
So as you can see, there's the general English. So we want to make sure that we didn't lose anything as we're going. And as you can see, as we trained, we didn't overwrite any of our knowledge. We didn't forget it. So that's really great. So now we have an idea of scale here. So it took me 3 weeks and a lot of time to record and get the data to improve the model for just 2 words, which is not scalable. What if I want to do 40 words? What if I want to do 50 words? What if I want to have, general pediatrics? There's a lot of use cases, and 2 words is just not going to cut it. So we have an alternative solution. Rather than collecting it ourselves, we can make a computer do it and generate synthetic audio. This is something that's already accessible by small companies. That's the last bullet point. It's highly realistic, computer-generated speech. It's that same audio file or recording that you saw, that you heard at the beginning of the presentation. That was an example that was using my voice to generate speech, and I did not say that. And as you heard, it was pretty realistic. This stuff, because it's computer generated, records approximately 2 times faster. And because it's a potentially automated process, meaning you could write a script that makes the computer generate the speech, and you don't have to actually do any recording, it can be even faster than 2 times. So you're looking at maybe an hour of work turns into like 10 minutes of data, which is actually a huge boost. So here's what I did to test if synthetic audio can be used in this way. Targeting about 50 vocabulary terms, I wanted to focus on scale, orders of magnitude more. I collected another 300 relevant sentences to those 50 vocabulary terms. 1 hour of data for both real and synthetic. So 1 hour of each. And then it's worth noting that in the real data set, there were about 11 unique voices, and in the synthetic, there were about 19 unique voices. So about, maybe double-ish, but overall, we have a bunch of unique voices for each. So the tests. So remember when I mentioned that we split the data? From the real data set, I split off about 7 minutes of data, and I put that to the side. We're not going to look at it. We're not going to learn from it. The model will never look at it until I want it to. For example, what might be inside of that test set is somebody saying the fascia is a thin white sheath of fibrous tissue enclosing a muscle or other organ. So somebody might say that. And then there was the general English data set that I pulled from online somewhere. And that would look like this example sentence. Do you remember that first walk we took together in Paris? So these are the 2 different tests. If the model can do good on both, then we have a great model that we want to use in our applications. So the results of using both the model trained with real data and the model trained with synthetic data, the error rate over time, you can see that over 8 steps of training, even after 8 steps of training, they were right. Their performance was very similar. They were highly correlated, and they learned at a very similar rate, both the synthetic and the real model. And both of these are being tested on just a data set of a real data. So this is really great stuff. But I wanted to be thorough. I wanted to make sure that we had thoroughly tested all the different configurations and parameters that we could pass our fine-tuning and training. And so for trial 2, we saw a very similar result. In fact, they both started going back up, so that's not that great. Then for trial 3, if anything, the synthetic data did better and learned faster, because synthetic data enunciates clearer, like computer-generated speech is more enunciated, less background noise, maybe louder. So it was actually able to learn those new sequences much faster. Well, not much, at a comparable rate, which is really great. And then there was the general English. We wanted to make sure, okay, maybe if we're training with synthetic data, are we forgetting how, what real voices sound like? And so the graph, looks like this. And I think it's pretty conclusive that we can use synthetic data to learn what real voices look like. And then on those same trials, trial 2 shows the same thing. And then trial 3 shows a similar story. So synthetic data has a lot of potential. There's more research to be done, but this is, like, we have to test scale and a few other things. But so why does this matter? Why do we care that we can use synthetic? I forget. So online solutions are losing favor. So we want to be able to use something that we can embed in our applications and make ourselves, and it's offline. So smaller companies can make specialized speech-to-text programs easier. Like I said, you could go to another big company and they could make big, large-scale data sets for your specific application, but that's going to be really expensive. In this case, you can just use a computer to generate large data sets and learn from that. So smaller companies have an advantage here. So it's really something that should be looked into. And then lastly, looking forward, this sort of shows that AI might be able to be used to train other types of AI. For example, a chess engine learning how to play chess from another chess engine, or image recognition software. So maybe you're training a model that can recognize human faces, but you don't have a certain type of facial feature represented in a data set. So then you can go to a face generating software and make data that way. There's just a lot of ways that you can use AI to train AI. And this shows that it's actually something that might be possible. So that concludes the presentation. And
All right, everyone, that concludes the presentation. Feel free to hang back and ask any questions if you have them. I hope you have a great day. Fake Ryan voice out.
mic drop. These are my references.
All right, everyone, that concludes the presentation.
Sorry
Feel
about that.
free to hang back and ask.
Yeah.
So you opened and closed with a really cool sounding synthetic version of your own voice. Can you tell us a little bit about the process it took to generate that?
So that was so that AI voice. I basically go onto their website and I click. They show me a sentence and then I click record, and then I speak the sentence and then I click save and then I submit it, or finish and then submit. And I did about 250 sentences recorded for them, and then they were able to make a model that represented my voice and the syntax that I use, I guess.
Did you have to weed out versions of your voice that were less accurate?
I did. I actually had a few different versions of some of these intros and outros. Asking my project manager, like, how does this sound? And yeah, so sometimes it was not as good as others. But I was actually really happy with the outro. It sounded a lot like my voice. That one I was able to get pretty quickly. The intro I had to play around with. In fact, it didn't do that great with my voice, or my name. When you listen to it, it says my name in a weird way, which just goes to show that the data that you train with is as good as your model can get. So the model of my voice is only as good as the data I give it, and I didn't necessarily say the sentences didn't necessarily have my name in it.
So to train this model to generate your voice, did you use the same sentence over and over, or did you use a variety of different sentences to train it?
So they probably have some sort of text base. Then they just select at random, and then they display that to me, and then I just say what I see, and then that's what they use.
Okay, and then from that point, once the model is generated, you can use that to generate audio for an arbitrary sentence that you simply need to type up.
Yes, yeah, pretty much. The words that you hear on the screen, I typed into the software, and then it generated it. Now, alternatively, if you wanted to do this in an automated way, like I said, somewhere on the slides, it's a potentially automated process. So there's an API that I can ping. I can send text strings, and then it'll send me the speech back. And that's a way that we can do this automatically.
Awesome, thank you.
Mm-hmm. Have you any other questions?
Are there any ethical concerns about using AI to train AI? Something that comes to mind is like facial recognition
Mm-hmm.
in minority communities. Like I know they've been outlawed in California, and so I didn't know if there's similar things using AI voice concerns in certain communities that colloquially would speak very differently or have different terminology. Is there something you can speak to that?
Just a quick clarifying question to bounce back. Are you asking specifically about lack of training for some of those, or are you talking about?
Essentially, are there like negative societal consequences of using AI to train AI?
Okay, I see. So the whole idea of these machine learning models is that they encapsulate a problem that we can't encode by hand. So that sequence to sequence the number of sequences that it's learning is so large that I could never hand do it per se. So I have to feed it tons and tons of data for it to learn from. And that's what machine learning is. In particular, this is deep learning, which is just a subset. But ethical implications oftentimes with machine learning is not having data that encapsulates the problem at hand. So if you need to deploy a model that can recognize speech in certain communities and you don't have data that represents that kind of accent or intonation, then you're going to be missing out on that. And so you're going to want to have data that represents that. So using AI to train AI, then it goes back to this new AI that you're training is only as good as the AI that you are using. So you do have a potential to just totally leave the world of reality and not incorporate, different communities and different new types of problems per se. So that is something to keep in mind. What I was doing with this is saying, okay, are we forgetting like how to recognize real speech? Can we extrapolate to real audio? That was the whole purpose behind the tests. And give me 1 second. There's a train of thought. So I've had this question a few times, and it has to learn these sequences. Let's say for eczema, like the CZ, that's the sound. It's pretty easy for it to learn one of those sounds, and most dialects are going to sound fairly similar with these vocabulary terms. We don't have to learn the entire word every way that it could be said. We just have to learn the general shape of what the audio might sound for each character. So to answer your question, the research shows that it might be able to generalize enough, but we're not. But you're eventually going to run into the problem of not being able to generalize to different communities. So this is a small fix for a small company to train in vocabulary terms for our use cases, but it might still lack. If you can't do this from scratch, you can't make a speech recognition model necessarily from scratch. Does that answer the question?
All right. I have a question. So those synthetic voices they used, were those already provided by Resemble? And also, do you plan, if they were, do you plan on like adding in having people contribute audio to use as synthetic voices in like future training of your model?
Yeah. So the question is, were those 19 voices that we used, were they all from Resemble?
Yeah.
A few of them were from another software. I took about half of them from another software, half from Resemble, were pre-made voices from these softwares, and all I did was feed them text and select the voice. As for adding new voices, going to coworkers and maybe asking them to record their voice and then using that, we probably will do that to the extent that is allowed by the software. So Resemble maybe has a limit. Maybe you can only make one voice. I haven't actually looked into that yet. But if we can, we want more variety and more accents and more speech and different. We want variety and uniqueness and as much as we can in our data.
Awesome. Thank you.
All right, cool. Thank you, guys.